Hi, I'm Dave with Optilogic's Customer Success Team, and today I'm going to introduce you to Cyclo, Optilogic's multi-echelon inventory optimization engine in Cosmic Frog. We're going to be using the Cyclo MEIO model as we go through the walkthrough today. Now, Cyclo helps you achieve a specific service level by answering the question, how much safety stock should I hold? And where? Cyclo is designed to help you guard your network against uncertainty, so you can hit service targets without holding more inventory than you need. Cyclo is Cosmic Frog's MEIO engine. The key thing to know is Cyclo's outputs are about safety stock and service time positioning across echelons, not about optimizing flows. This demo model is a Western Europe network. Suppliers feed a primary DC in Rotterdam, which feeds 8 secondary DCs, which serve 144 customers. We'll use it to illustrate the MEIO concepts. To understand Cyclo, you really only need 5 inputs: a fixed network, lead times, variability, service targets, and cost. Let's explore those in the data module in the input tables. First is the fixed network, basically defining where the product can flow. Now, if you're single sourcing, transportation policies alone is enough to define that network structure. And if you need to model multi-sourcing splits, that's when you can use customer fulfillment policies and replenishment policies, typically with a buy ratio approach. Next are lead times. In Cyclo today, lead time is captured through transport time in Cosmic Frog. So if you want to represent production or processing time, you'll roll that into transport time for now. One important thing to note here is that Cyclo doesn't optimize transportation lane selection. Instead, it assumes every lane you define in transportation policies is an active flow path. So if a facility has multiple inbound or outbound lanes, Cyclo assumes flow can occur through all of them and uses all available lanes during demand propagation. Next is demand variability. In this model, we use customer order profiles where you provide a demand distribution directly. If this is the table you use, make sure to provide time between orders, as Cyclo will stop the run if any time between orders is missing. The alternative is customer orders, where you provide historical orders and Cyclo calculates the statistics for you. This model includes 2 demand sets with the same average demand but different variability. We've designated these with the suffix new or orig for original. This will illustrate how reducing variability reduces safety stock and cost. So for example, the demand for order 0001 on the screen has a mean of 710 and a standard deviation of 80 originally, whereas the new demand has the same mean but a lower standard deviation of 72. Next is service. In inventory settings, you set your global target service level. This model uses 95% as a baseline, and you choose a service type, where service type 1 is the probability of stocking out, and service type 2 is the quantity fill rate. Conceptually, you're telling Cyclo what good service means, and it will size safety stock to hit that target. And if you ever need to override service targets for a specific location product combination, you can do that in the Inventory Policies Advanced table. Then we have cost. Unit value and inventory carrying cost percentage are key because Cyclo translates safety stock into holding cost, so you can compare scenarios in whatever currency you're using, not just units. And if you need more detail, those global values can be overridden to be product location specific in the Inventory Policies table. Okay, now that we have gone over our required inputs, now comes the fun part: scenarios. This demo includes a set of target service level scenarios: 85, 90, 95, 97, 98, and 99%. So we can learn how cost and safety stock change as we push service higher. And it also includes a few classic what-if scenarios, like less demand variability, reduced ocean lead time, and a scenario where we hold no safety stock at the primary DC, so we can learn how safety stock shifts across echelons. To run Cyclo, we click the Run button, select which scenario or scenarios we are interested in exploring, such as 97% service, less demand variability, maybe reduced ocean lead time, and then we'll click Run. Okay, now that the run has completed, there's a couple things I want to show you in the analytics module. Couple of specific dashboards. One is the MEIO cost versus service dashboard. This dashboard shows us the trade-off curve. So as we push toward very high service levels, costs tend to rise faster, especially as we get close to 99% here. And the second dashboard, MEIO safety stock at DCs, shows us where safety stock is sitting across distribution centers. It's filtered to the 95% target service level scenarios, so we're comparing apples to apples. But we can change which scenarios are shown if we want to explore other comparisons. Now, if we want the roll-up numbers behind those visuals, let's go back to the data module, go to our output tables. There's a couple of specific output tables we'll want to explore. The first is the inventory network summary. This gives us the big picture, total safety stock, total cost by scenario, so we can compare service targets, variability changes, and lead time improvements. And then let's go to the inventory safety stock summary for the details. This shows us the demand statistics Cyclo used, how it positions service time across stages, and the resulting safety stock and holding cost contributions at each node. One quick note before we wrap up. Cyclo today is single period. It supports demand variability, not lead time variability, and it represents lead time through transport time. So just keep that in mind as you model. And that's the basics of Cyclo. If you want to explore MEIO hands-on, open the Cyclo MEIO demo model from the resource library, run a few scenarios, compare the outputs, and then map those same levers, service, variability, lead time, and cost, to your own multi-echelon network. Happy modeling!